Hello, everybody. So today we're going to go in and go ahead and get started on our first chapter of stats. So today is largely going to get us kind of used to going through the process, used to what the lectures look like, as well as used to what the quizzes are going to start looking like, the homeworks. But today's basically just going to be a lot of more vocab type stuff, and just get used to the format. So one of the first questions we're going to ask is taking a look at why stats. So we talked about this a little bit in the opening class. This essential idea of why are we looking at statistics? Because as we've talked about before, we're talking about sociology broadly, is that we're trying to understand the world in order to maybe make it a better place. We're trying to understand the world in order to maybe transform it. So stats is one of these versions of how we tell our stories about the world to make sense of who we are. And of course, this has ways of narrating in our own lives and has real consequences on the world. So we go a little bit further. What is statistics? So statistics officially, the term we get from the textbook, is a set of procedures used by social scientists to organize, summarize, and communicate numerical information. And one of the main things to remember with this, and we'll go into a little bit more about that in a second, is that only information represented by numbers can be subject to analysis. So statistics is a type of language, it's a type of way of us telling a story about ourselves and society that has to be something that's numerical, something we could quantify. We can't necessarily talk about feelings, so not necessarily feelings, or if you were in another part of sociology, you might also think of things like spirituality. Statistics isn't really good for things like this, though maybe we could come up with ways to make these into numbers. It more has to be things that you could quantify. So we say the word quantify. Basically, it just means we can make things into numbers. So this is the sort of thing we want to be looking at with statistics. Statistics is a strong language to help us understand things that we can quantify. So, um, while stats is used in several ways of narrating our lives, we talked about that has real consequences. So, what we commonly think of as something that's and there's two parts here I want to point out. What we commonly think of stats as something that's absolute, true, and objective. Something that's not necessarily subject to someone's opinion. I want to emphasize too is it's also a creative process, and we'll look at this throughout the semester a little bit today, and how you use numbers. So just because something is a number doesn't necessarily mean it's going to be objective. So just because something is a number doesn't necessarily mean it's not going to have somebody's opinion in it. And we see this maybe if you start thinking about political data. So if we're taking, say there's a survey done on people who they're going to vote for in the next election, someone's opinion might shape how they collect that data. And we'll look at different ways that this happens. But if someone, for instance, was supporting one candidate over another, that opinion might shape exactly how they end up collecting the data and what story they end up telling about it. So I do think that though we're using numbers, it's still going to be based on someone's opinion and perspective. But our goal is to try to limit that as much as possible. And it may be because someone wants to convince or mislead you for something. One little data point here. I try to bold the definitions. So within this then, data, we talk about that a lot. It's basically just procedures to analyze data, to answer research question and test theories. So it has to do with procedures to analyze data. Data being something that we collect and use to tell our story. So if statistics overall, if the big idea of statistics is here, statistics is here, we use things like data and numbers to tell our story. So statistics is the whole picture, data helps us tell the story. Okay, so basic idea of statistics. Now there's next section we're going to go into three parts of how do we do statistics. So I'll go through an overview of how we do it, and then we'll go through a little bit more information on some of these pieces here. So basically a research process. So if we want to tell a story in statistics, There's steps to telling that story. So, like if you have ever been in an English class, maybe there's an introduction, and then maybe there's a rising action, then there's the conflict and conclusion. Statistics has a similar process, but we want to tell it in a certain way. So, the way we use stats to tell our story, we use a similar process. But we're going to actually use this process in this semester. We'll go into that a little bit later. But step one is asking a research question. So one of the first things you want to do before you ever embark on a statistics story or trying to find an answer to something is asking a research question. So specifically, what are you interested in researching? What seems to be interesting to you, to me, or to us? So some of the topics we talked about in the intro was something like looking at homelessness or poverty, things like that. Poverty, homelessness. So maybe it's a topic we're interested in. So then maybe formulating a hypothesis is the second step. And we'll go into more definition what formulating what a hypothesis is. The second step is if you've identified a problem, if you think that, for instance, in our example here of homelessness and poverty, if you think that these things are related to each other, your hypothesis would maybe be saying why. So I might say homelessness and poverty are related because the more poverty there is, so my hypothesis might be poverty. So actually, let's try this. So the more poverty there is, the more likely people will be homeless. So your hypothesis that is basically an idea of trying to tell us why you think the story is, and you're going to go and investigate that. So if we were looking at this particular question of if you were interested in looking at the idea of poverty, then and trying to see how it's related to homelessness, your hypothesis might be that if there's more poverty, there's going to be more homelessness, just because people are unable to, afford paying rent, and especially in Southern California, right? So this idea that a hypothesis is simply a reason or a story why you might think something is happening. So your research question, what you're interested in looking at. In this case, we were talking about homelessness and poverty. A hypothesis is going to be why do you think this is happening? So the difference between them, the next step, is kind of what separates a story in statistics from telling a story in English. So in this sense, we're going to want to collect data to go see why you think the story might be. So in our example, when we're talking about homelessness and poverty, you might actually go do a survey, for instance. So your survey might be something like this. So you might ask us a survey and ask, what caused your homelessness? Or what caused your homelessness, or something along the lines of what caused you to be in the circumstances where you're unable to afford rent. Maybe that's a better one. What caused your circumstances to where you couldn't pay rent? So then your survey might be to go ask folks you've already identified as being homeless, and then you want to go check to see how folks might actually answer the survey question of what caused their homelessness. So in this sense, when you're doing you're collecting data, so your first step has been asking the research question, poverty and homelessness, what's their relationship? Your hypothesis is the more poverty there is in a community, the more homelessness there will be. Then you go ahead and collect data. In this case, you want to actually ask folks why they might actually be suffering, why they are finding themselves in a certain situation. So we've collected data, which means you're going to collect information directly. And remember, collecting data in this point is best served as numbers in statistics. So then the next step would be analyzing the data. So you'd go through and say you collected 500 surveys, and you found that yes, indeed, that most of the people that answer that survey were actually facing poverty or having lost their job or something before. So then when you're analyzing your data, you're going back and looking at this to see what story the numbers can tell. And finally, at the last step, you evaluate your hypothesis to see how you did. So you might go in and go back and see that, okay, yes, indeed, it seems that 400 out of 500 people that took the survey were facing poverty, who are also homeless. So then you might actually make the argument then that your hypothesis, your idea of how these things might be related, was true. Okay, so it's a story technique in 5 steps: asking the question, formulating a hypothesis, collecting the data, analyzing the data, and evaluating the hypothesis. So as far as we're concerned at this part of the semester, just be good for you to know these basic ideas, and we're going to keep on coming back to these probably almost every week. Okay, so that's the basic story of looking at statistics. So as we've got the basic idea down, there's a few more things I want to go in a little bit more detail on. So how do we do statistics? So when we're looking at understanding the language of stats, and I emphasize language here because some of these things might seem unfamiliar to us. But these terms are going to be essential for us to be able to make sense of this world of statistics. So one that we'll look at the word theory. This is basically a set of assumptions and propositions, and it's used by social scientists or sociologists to explain or predict a phenomena. So for instance, in our last one, in our example of poverty and homelessness, if you were to go in and study this in cities all across the United States and found that this seemed to be the same in all cities, you might start developing a theory that there's some inherent relationship between people in poverty facing homelessness situations. Okay. Second one, formulating a hypothesis. We talked a little bit about this. Basically, the hypothesis is an idea of an explanation, an idea of how two things are related to each other. And an important part here, basically, it can be affirmed or denied based on testing. So in our example of connecting the two, if we had done this survey and found the other way, as instead of 400 out of 500 people were who were surveyed, who were facing homelessness, were in poverty, if you would have gone the other way and saw something like 400 and 500 people were actually wealthy, but also facing homelessness, then you would have denied your hypothesis. Basically meaning that when you collected the data, when you sought out the information, it turns out maybe you weren't right about this. So hypotheses are important because they can be proven one way or the other. This is the thing you're trying to say yes or no to. And that is linked with the third part here of testing a hypothesis. So basically, when testing a when testing your hypothesis, you're looking at two parts. And it gets more complicated when you get into later ones, but the basic idea is you're looking at cause and effect. So let's go back to our example again. Poverty and homelessness. So basically, in this thing, we're saying, my hypothesis is that poverty is causing homelessness. So this is the cause, and this is the effect. Cause and effect. So as far as statistics are concerned then, when you're looking at cause and effect, you're interested then in trying to understand how one variable, in this case poverty, is going to relate to the other variable, in this case homelessness. So in statistics we call the cause is the independent variable, and homelessness is the dependent. Independent and dependent. So independent variable is the thing that causes the dependent variable to happen. We'll go look at here in the actual definition. So dependent variable is the one that the researcher wants to explain. The independent variable is the one that is expected to cause the explanation to happen. Whereas the dependent one is the one that's being explained by the other. So in our hypothesis, when we're trying to see how poverty and homelessness are related to each other, we're hypothesizing that poverty is causing the effect of homelessness, or the independent is causing the dependent. So the important terms to remember now are just independent and dependent variables. These will help you in the future. So when you find yourself, if you ever trying to figure out how to distinguish these two things, just listen to yourself speak. For instance, I think that long hours of studying will help you get good grades. I think that long hours of studying will help you get good grades. So in that one, you're seeing that studying causes the effect of good grades. So here is the cause, study is the cause, grades are the effect. Study is the independent variable, grades are the dependent variable. So just when you're speaking an idea out loud between two things and how they're related with each other, the one causing the other to happen is the independent, and the one being caused to happen is the dependent variable. Okay. So we'll also be going over that in the next few, kind of throughout the semester. A few other terms just to take a look at. So in that step where we're talking about collecting data, we'll be looking at this more in the future, but our basic thing we'll be looking at is the General Social Survey. So basically what the survey is, it's a survey that's been since the 1970s. And this General Social Survey is basically asking questions like, what class do you consider yourself? Have you ever been hospitalized? Have you ever witnessed a crime? I mean, they ask thousands of questions to people every year since the 1970s. And what this is useful for is now there's this big data set that we could actually use online and explore these variables and actually start trying to anticipate or predict how one variable might cause another. So the reason this is useful for us is as we start thinking about how data is used, we could actually start seeing how statistics takes place in the real world. So the GSS General Social Survey data is something you could take a look at, and we'll take a look at it in the coming weeks on how data actually is used in the real world to predict things that are going to happen, in order to start seeing how populations are changing over time, and things like that. So collecting data, it's always important to have a set of data on where we get this information from. So that's part of the collecting data. A little bit further down is part of interpreting. So I want to do a little bit of a distinguish some things here. So two terms we're going to see a lot is sample and population. Sample and population. So a sample is a smaller group of something, whereas population is the whole group you're interested in. So for instance, if you were, as we're talking about the election, you're talking about a presidential election, for instance, and you wanted to find out who you thought was going to win based on asking people who they were going to vote for. So in this case, if we're talking about a U.S. election, the whole population, in this case, is the whole U.S. population, is everybody in the United States. Whereas the sample is the group of people that you actually ask the question. So for instance, if you were going to do a survey, you wouldn't be able to ask everybody in the United States who you're going to vote for. You might just ask a sample of maybe 50 people. So there's 50 people that you ask who you're going to vote for. That would be a sample. And that sample of 50 people is supposed to represent the entire population. So sample is always whatever group you're actually asking, and that sample is supposed to represent the overall group. It could be done the same way in a classroom. So if you wanted to find out what people thought in your college, whether or not they were satisfied with their school, so the college itself, that would be the population. But maybe since you're not going to be able to ask the entire college, you would ask maybe one classroom. So this class of people that you ask, that would be the sample. So these are always going to be from the same group. So a class is a sample of the college. A class is a sample of the college, which is the population. Okay? So as far as we're concerned when we're moving forward with this, sample versus population, we'll be using that term a lot. So when I say a sample, I'm talking about a small group, and population is the overall group that I'm interested in. Okay. So another distinguishing thing you might want to have here is going to be between descriptive statistics, bolded there, versus inferential statistics. So descriptive statistics, this is mostly where we're going to be this semester. In any intro class, you're mostly going to be looking at descriptive statistics. And these are basic ways of you putting information together to better understand a group. So descriptive is usually going to be like step one of the process, is to understand a group. And step two is going to be more of the inferential. So inferential is the predictions you're going to make based off the information that you have. So for instance, descriptive would be something like what a group of people said they were going to vote for. So in our example of the election, it'd be saying who are you going to vote for, and it's that information we collected. Who are you going to vote for? And number two, the inferential would be a prediction. We'd be maybe using all that data and all the information we found to predict who was going to win the election. So descriptive is simply describing a population, describing a sample, putting information together, organizing it, categorizing it, and even in the word describing it. Where inferential, the second one, is predictive. So we're taking all the information we have about a topic and we're going to make a prediction on, in the election example, on who is going to win the election. Okay. So this one here, this is something we're going to be looking at a lot, looking at these terms here. So when we're looking at variables, and variables in this case is basically anything that you're looking to measure. So we were looking above, poverty was a variable and homelessness was a variable. It's anything we're interested in looking at. So when we're describing variables, there's 4 different names we could come up with any variable. Okay. So for instance, nominal is the, so if we think also, let me also do a little chart here. So if you think about all these on a spectrum, this first one, number 1, nominal, is probably the closest to, this will make sense in a second, not numbers. Or on the other end, not number. Or on the other end, it's going to be closest to being numbers. I'll show you what I mean by that. So nominal is in name only. It's a name of a measurement, and you can't really put a number to it. So nominal would be like someone's sex, someone's political party. So someone's sex, someone's political party. The basic idea being you can't actually put a number to it. So let's just type it like this. So sex, political party, someone's, if they're like a freshman, so their class rank. And these are all things that you could talk about that don't necessarily have numbers associated with them. So for instance, when we're talking about the idea of sex as male or female, the idea would be that a male versus female, neither one's really a number. Neither one you could really say is better or worse than the other. It's just arbitrary. So nominal, and I highlight here, it's a name only. So it's just a name. So political party, a Republican versus Democrat, neither one is necessarily better than or can be ranked differently than the other. It's just a name. So nominal is just a name only, and it's very close to being not numerical. Okay? Second one, and this will make more sense as we go through it. Ordinal. So it's a little bit closer to numbers because you can, and I have it highlighted here for you to remember, can be put in order. So we often see ordinal levels of measurement if you've ever gotten a survey before, whether it's for a class, maybe for a restaurant. If you said on a scale of 1 to 5, how satisfied were you with this your meal today for a restaurant, or how satisfied are you for your service with anything else? One would be, like very satisfied, strongly agree, versus all the way to the other end, strongly disagree. So ordinal in this case is something that could be ordered because you can see that there's a 1, 2, 3, 4, 5. However, you can't really tell what's in between these two things. You can't really, in the sense of you can't really tell how much space there is between someone who strongly agrees versus somebody who just agrees. Or if you were to compare two people's different opinions. So if I were to say person one and person two, and both of them answered a two on this survey. So both of them agreed that this was true. So because it's on ordinal scale, you can't really tell the difference between person one and person two. They both agree, but what one person's agree is versus another person's agree could be completely different things. So ordinal means you can rank it in order. You could tell the difference between one person's opinion, but you can't tell between comparing it between two or more people. Okay. So the next stage is to go a little bit further down this scale. Is I like to lump these together because they're both very close. So the 3 and 4 are interval. So that's number 3, interval. And number 4 is ratio. So these are very similar. And both of these are closest to being numbers. So these ones are very close to this end, 3 and 4. They're very close to being purely numbers. So both of them, we could order it just like we could before with ordinal. So they have everything that came before it. We could order it. We know the difference between the numbers. So the difference between the two is interval and ratio has to do with the number 0. I'll explain what that means. So interval, for instance, it doesn't have a concept of 0 or nothing. So the example I like to give for that is temperature. So if you have something like someone's temperature, if you say it's 50 degrees outside, it doesn't make sense to have 0 in this sense as in 0 temperature. So you could be 0 degrees, but 0 degrees isn't the same thing as saying 0 temperature, because 0 degrees is still a temperature. So this is interval because the 0 actually still has a value. Whereas in ratio, there is such thing as a 0. You can have a 0 in ratio. So the best example of this are height, weight, and duration. So for instance, you can have some 0 height. You can have something that's 0 feet tall or something that's flat. You can't have 0 weight, like someone who's you can't have no weight, as in 0 pounds. And also you could have duration, like 0 seconds or 0 minutes. It's something that makes sense in this framework. So if interval versus ratio, the best thing to remember is just the 0. And on the scale, ratio is the furthest and closest to numbers because it actually has a 0 that makes sense. So if you're trying to understand the difference between these two things, just remember the difference between temperature and all these other ones, height, weight, and time. Because in the one instance of temperature, there's no such thing as having 0 temperature. You could have 0 degrees, but temperature still exists, right? Whereas 0 pounds, you can't have something that weighs nothing. Or 0 minutes, you can't have something that it doesn't take any time at all. Okay? So we'll continue to go through these the next few weeks. But the main thing is just to remember, I like to remember the scale, 1 to 4. And the further down the scale you go, the more number-like it becomes. Whereas on the front end of the scale, towards the 1 nominal, there's no numbers really involved other than arbitrary things. So nominal levels of measurement are arbitrary. So basically, political party, Republican, Democrat, male, female. Ordinal, you could put them in order. However, you can't really tell the difference between a strongly agree versus agree. So it's not as precise as interval or ratio. Whereas ratio and interval, they both, you could tell the difference between what is 1 degree and 2 degrees in temperature. And you could tell the difference between 1 pound and 2 pounds. There's exactly 1 pound difference. However, 0 is the difference between these two, and 0 in the interval is the one, 0 in the ratio has an actual, makes actual sense. Okay, so one of the final things we're going to go through, and again, I'm sorry about all the definitions this time, but generally what chapter 1s are like. One of the final things we're going to talk about with our variables is discrete variable versus continuous variable. Discrete versus continuous. So the main idea, these make the most sense through examples, is discrete is something you can't really break down. It doesn't make any sense to break it down. Whereas continuous is something that could continue on forever. So a discrete variable is something like the question of how many children do you have? So in this case, if a discrete variable is something that can't be divided, in this case, a child is not divisible. So if someone were to ask you how many children do you have, you wouldn't say 2.5. You either have 2 children or you have 3 children. So discrete then means it can't be divided. It wouldn't make sense to divide it. Whereas continuous is more number-like, something that could go on forever. So I like to use length as an example here, because length itself could be forever divided. Um, for instance, if you're talking about inches, 1 inch versus 2 inches, if you're talking about length, 1 inch to 2 inches, you could also divide this up further in between, and it would make sense in this case to say 1.5 inches. That is still something that makes sense. Whereas with the children example, you have one child or two children, but it doesn't make sense to say 1.5 children, for instance. So continuous is the one that you could divide up. It continues on forever. Versus discrete means you can't break it down, you can't divide it. Continuous versus discrete. So that'll be the basic idea. So as far as this goes, if you want to go back and take notes, just make sure you get these definitions written down or go back and explore the video. But as far as our quiz is concerned, it's going to be made up of these sorts of definitions, and it'll be sort of a quick first crack